Hello everyone, I am Shravanth. So the problem we have today is integral is equal to between the limit 0 to pi x sin square sin x plus cos square cos x dx. Before going into the formula, let's see the properties we used in this sum. The first property is integral if the first integral is integral between the limit 0 to a x f of x dx, we is equal to a by 2 integral between the limit 0 to a f of x dx if we can prove that f a minus x is equal to f of x. The second property we use in this sum is integral between the limit 0 to a f of x dx is equal to 2 into integral between the limit 0 to a by 2 f of x dx if we can prove that f of a minus x is equal to f of x. The third property we use in this sum is integral between the limit 0 to a f of x dx is equal to integral between the limit 0 to a f of a minus x if f of a minus x is not equal to f of x. And apart from these three integral properties, we use another trigonometric identity here, which is sin square x plus cos square x is equal to 1. So let's look into the question. The question given for us is integral is equal to 0, integral between the limit 0 to pi x sin square x sin x plus cos square cos x dx. Here we have a problem.
This is sin squared of sin x.
Okay, sir. Here we have the problem of this question is in the form of x f of x dx. So when seeing this question, the first thing that comes to our mind is integration by parts, but that would complicate the situation here. So what we do is we remove this x by applying this trigonometry, integral property. We can apply this integral property if we can prove that f of a minus x is equal to f of x. Here we take a is equal to pi. So when applying this property, f of a minus x, that is f of pi minus x, is equal to substituting the value of pi minus x in the places of x, which gives us sin square of sin of pi minus x plus cos square of cos of pi minus x. Sin of 180 minus theta is sin theta, so it is the sin square of sin x plus cos of pi minus x is cos of minus x. But we also know that cos of minus x is equal to cos x, gives cos x. So I get sin square of sin x plus cos square of cos x, which is equal to the original f of x. So we have proven here that f of a minus x is equal to f of x. If we prove that f of a minus x is equal to f of x, we can apply this integral property, which is 0 to a x f of x dx is equal to a by 2 integral between the 0 to a f of x dx. I am doing this to remove the x in the x f of x dx. So after applying this property, I get integral is equal to pi by 2, which is a by 2, and here a is pi, so pi by 2 into integral between the limit 0 to pi sin square of sin x plus cos square of cos x. Here I am again applying the integral property, which is 0 to a f of x dx is equal to 2 into integral 0 to a by 2 f of x dx. Here my intention is to convert the upper limit into pi by 2. So applying this property, we can apply this integral property if we prove that f of a minus x is equal to f of x, which I have already done here. So after applying the second property, I get I is equal to pi by 2 into 2. The 2 and 2 gets cancelled. Integral between the limit 0 to pi by 2 sin square sin x plus sin square of sin x plus cos square of cos x dx. So the next thing is in this integral we get that f of x is equal to sin square of sin x plus cos square of cos x. Then I am again want to prove that f of a minus x is not equal to f of x here. So I am going to prove that here f of a minus x, a is taken as pi by 2. Here the first one we get a is equal to pi, here a is equal to pi by 2. So applying this f of a minus x as f of pi by 2 minus x, applying the value of pi by 2 minus x instead of x, I get sin square of sin of pi by 2 minus x plus cos square of cos of pi by 2 minus x. Sin of 90 minus theta is cos x, so I get a sin square of cos x plus cos of 90 minus theta is sin x, so I get cos square of sin x. here we have proven that f of x is not equal to f of a minus x because it's sine square of sine x and it's sine square of cos x. Since f of a minus x is not equal to f of x, I apply this property, which is integral between the limit 0 to a f of x dx is equal to integral between the limit 0 to a f of a minus x dx. So applying this property here, I get I is equal to pi into 0 to pi by 2 sine square of cos x plus cos square of sin x dx. So I am taking this as equation 1 and equation 2 and adding them both. When I add them both, I get pi 2i is equal to 0 to pi by 2 sine square of sin x plus cos square of cos x plus sine square of cos x plus cos square of sin x. Here, if we note carefully, we get sine square of sin x plus cos square of cos x plus sin square of cos x plus cos square of sin x. Here I am assuming as sin x as a and cos x as b. So substituting the value, we get sin square a plus cos square b plus sin square b plus cos square a. So if we group the like terms here, sin square a and cos square a, sin square b and cos square b, which is sin square, applying the integral property, sin square x plus cos square x
Integral identity.
trigonometric identity
Trigonometric
is equal to 1. So sin square a plus cos square a is equal to 1 plus sin square b plus cos square b is equal to 1, which gives us 2.
So sin squared a, you can put sin squared a plus cos, okay. Since you have put a, so a, you can write sin squared a plus cos squared a is equal to 1. Similarly, sin square b plus cos squared
b plus cos square b is equal to 1. So adding these two,
it is reduced to 2.
this whole equation is reduced to 2, and since 2 is a constant, I bring it outside of the integral, which gives us 2 pi integral 0 to pi by 2 dx. Integrating dx, we get x between the limits 0 to pi by 2. Applying upper limit minus lower limit, we get 2 pi into pi by 2 minus 0. That is substituting the value of pi by 2 and 0 in place of x. Pi by 2 minus 0 is pi by 2, and here 2 and 2 gets cancelled. After 2 and 2 gets cancelled, we get thus 2i is equal to pi square, that is multiplying both of the pi's, and bringing this 2 down here, we get I is equal to pi square by 2 plus c. So this is the answer for the
actually that is, we need not put integral constant there because it is the definite integral. So no need for
constant.
So we are evaluated nicely. I is equal to half of pi square. Okay, good, very good.
Thank you.